So guys, today we'll be solving Codeforces round 953 div 2, and this was a pretty easy contest as I was able to solve up to E. So let's quickly get to the solutions. So here we have problem A. Alice has n books. The first book contains AI pages, second book contains A2 pages, A1 pages, A2 pages, and so on. And she divides all the books into two non-empty files. Thus, each book ends up in exactly one of the two piles. Alice reads one book with the highest number in each pile. Okay, so there are two piles in the in the whole array, and we have to divide the total number of books in two piles. And here the number refers to not the number of pages, but actually the serial number of the book, right? So since the highest number is taken, it is a very clear observation that one of the piles will contain the last book as it has the highest number, since it has to go in one of those piles. And in the second pile we can actually choose which indices we choose, so such that the number is the highest. So we can already say that answer of one of the piles is the last number, and uh, in the second pile we'll keep the whatever the maximum is in all these, because we can choose any of these in one pile and all the others in the other pile. So the solution is very simple. We'll take the maximum of these and add it to the last element, and that will be our answer. So let's get to the solution. Uh, Here you can see that uh, just let me zoom it a bit. Yeah. So here you can see that the solution is, we have taken the input of vector, the input n, and then the maximum of all numbers from 0 to n minus 1, and uh, the answer is the last element plus the max. So this is the answer. Okay, so now let's get back to the second problem. So Bob decided to open a new bakery. On the opening day, he baked n buns, which he can sell. The usual price of bun is 8 coins. But to attract customers, Bob organized the following promotion. So Bob chooses some integer k between 0 and n, or b, whichever is the minimum of those, and he sells the first k buns at the modified price. In this case, the price of ith, so the bun is b minus I plus 1 coins, okay? And the remaining n minus k buns he sold at a coin c, right? So k can also be 0, right? So you know up to k buns he will be selling at price b minus I plus 1, and the rest of the buns he will be selling at price, the regular price, the a price. So we have to find that uh, help determine the maximum profit he can obtain selling n buns. Okay, so what are the constraints we have? Okay, n, a, b are up to 1 in 9. So obviously we cannot iterate between any of these n, a or b one by one, as this would exceed a given time complexity. So we'll have to think of a mathematical solution for this. So let us get to the solution here. Okay, so the price of ith bun is b minus I plus 1, right? So the price of first one will be b minus 1 plus 1, that will be b. The second one will be b minus 2 plus 1, that will be b minus 1. And the third one will be b minus 2, and so on, right? Up to some number, up to kth element, and from then onwards the price is a, right? This up to nth element. So what approach can we do such that the profit is maximized, that he can sell all the buns at the best possible price, right? So first consider what will happen if a is greater than b, right? If a is greater than b, what will happen? The first one is being sold at b minus b, and the second one is sold at b minus 1. The third one will be sold at b minus 2. So all these prices up to the kth one, whatever k will be, that will of course be uh, less than a, right? B minus I will be less than a. So of course we'll be choosing k0, and we'll be selling all the buns at price a. Sell at rupees a, right? Yeah. So we'll be selling it at a price, and the total cost price will be n times a. That will be our answer. And in the second case, we have if A is less than equals to B. Okay, let me just clear everything here since we have gotten our explanation. So we have if A is greater than B, then answer is n times A. Now consider the second case, if A is less than equals to B. Then of course it's possible to sell at the price B, right? And we can keep going till we reach A. For example, consider we have some price, the starting price is B, the second price is B minus 1, and so on. And at some point at the kth element we will stop, and from then onwards we'll be start selling at A price, right? A, right? Now consider that what will be this element, the kth element. Of course, this will be the B minus K plus 1, right? So this element is B minus K plus 1, and from then onwards we have A price, right? So now think, to maximize the profit, what can be the best strategy? Uh, okay, so suppose this element is greater than A, right? This element is greater than A, which means we can still decrease this element till it reaches A, which means that we can get some more profit. So basically, till when can we keep decreasing B, right? B will keep decreasing from here onwards. Till when can we keep decreasing B? We can keep decreasing B till B reaches A, right? B minus 1, B minus 2, and so on till B reaches A. We can keep doing this, and then we can sell at A, because if we decrease further, then it will be A minus 1. So we don't want that. We have other options. We can also sell at A. So why not sell at A only? So our strategy will be, if we keep decreasing B one by one and reach A, then we stop and sell the rest of the buns at A price. Okay. So now just a thing remains to know, that what will be this sum. Okay. This sum will be what? A plus 1 plus A plus 2 plus until B. This will be the sum, and the rest of the sum will be A into this length. Let's say this is L for the moment, A into length, right? This will be the sum. So now there's just one another case. What if B is always greater than A? If that means if I decrease B minus 1, B minus 2, and so on, and till the nth element, B minus n plus 1, right? That is still greater than n. So we sell all the elements at this price only. We never use A because we get the maximum profit with this strategy. So if B minus n plus 1 is greater than A, then we just sum of these values. The sum of these values will be 1 plus 2 plus up to B minus 1 plus 2 plus up to when? This is B minus n plus 1, so this will be B minus n, right? So we can use the formula of summation of 1 to n, that will be n into n plus 1 by 2. We all know that, right? Okay, so let's just clear the screen. So we got to the conclusion that if B is if B is less than A, then we'll just the sum will be n times A, and otherwise the sum will be summation of B minus 1 up to A plus 1, and then summation of A till the rest. Okay, and if B is always greater than A, that is B minus n plus 1 is greater than A, then the sum will be summation of B minus summation n from 1 to B, and summation of n from 1 to B minus n. Okay, so this can be easily found when will be uh, you know what will be this sum? So this will be just summation of n from 1 to b minus summation of a n from 1 to a. That will be this whole sum. And what will be this length? This will be b minus b minus a plus 1 plus 1. This will be the length of this segment. So basically this is b minus a, and the length of the rest of the segment is a times n minus, okay, n minus b minus a. Sorry for the bad handwriting, I'm using mouse. So yeah, this will be the whole summation. So let us see how we coded this up. This is pretty fundamental. Okay, so here we have taken the input of n a b, and if b is less than equals to a, that is a greater than equals to b, then the answer is n times a, and else we have the summation. So we have taken this summation of n. We have taken this summation from 1 to b minus 1 to a plus a times n minus b minus a. See, it's b into b plus 1 by 2 minus a into a plus 1 by 2 plus a into n minus b minus a. This is the sum we will be taking. But again, if b minus n plus 1 is greater than a, or b minus a plus 1 is greater than n, you can take any of these conditions, both are equivalent. Then we have taken an integer x equals to b minus n, and then we have taken the summation from 1 to b minus this summation x into x plus 1 by 2. As I talked about, this is the summation we are talking about, b minus a. So yeah, this is the difference we'll take, and that will be our answer. Else answer will just be the sum. So yeah, that's for the second question. So guys, we have submitted B, and now we'll proceed on to the next problem. Uh, Actually, let's get back to C sometime later, as we'll sort out the easy problems first. And yes, I think D and E were easier than C in this case. So let's just solve D first. Okay, so let's read the problem statement. Elections have taken place. There are n candidates participating, number from 1 to n. The ith candidate has AI fans who will vote for him. Okay. Additionally, there are C people who are undecided about their favorite candidate. Let's call them undecided. Okay. So the undecided people will vote for the candidate with the lowest number. So these C guys will vote for the candidate with the lowest number. Again, I think the thing number here is a bit ambiguous. They should have mentioned the index, ith index, but in this case, you just consider that the number is the index. Okay, so the candidate with the lowest index, he will get the vote of these undecided citizens. Okay, so now the candidate who receives the maximum number of votes wins the elections, and if multiple candidates receive the same maximum number of votes, the candidate with the lowest number among them wins. Okay, so if multiple candidates have the same number of votes, then the candidate with the minimum index wins the election. Okay, so now we have to find from 1 to n the minimum number of candidates that need to be excluded from the elections for candidate number I to win the elections for each I from 1 to n. Okay, so we have for each I from 1 to n, for each index, we'll have to calculate if that particular candidate has to win the election, then then which candidates do we have to delete from the array. Okay, so what can be approached? Okay, so let's take a look at the constraints. We have n varies from 1 to 25 and c varies from 0 to 109. Obviously, c has nothing to do with this, it's just a number, so we don't have to do anything with c. And ai belong from 0 to 109. Okay, that's not a big deal. Uh, what can be the approach to this problem? First, let's see when does a candidate win the election. So a candidate wins the election when he gets the maximum number of votes, right? So suppose this first candidate has to win the election in this particular test case. Let me just write it down, 31203. So it's okay. So let's have this test case 31203. Okay. This is the number of undecided candidates. This is the C, and this is N, and this is A, array A, right? The first candidate has 2 guys voting for him, the second candidate has 0 guys voting for him, and the third candidate has 3 guys voting for him. So if we don't remove any candidate, then obviously the third candidate is winning the elections because he's got the highest number of votes. Okay. But we have this C, okay, which says that they will vote for the lowest index candidate. Okay. So if no index is removed, then we have the first candidate gets 2 plus 1 votes, the second candidate still gets 0 vote, and third candidate gets 3 votes. So these two guys have the same number of votes, and the first guy will win the election irrespective of whether someone is removed or not, because the guy with the lowest number index wins in case of a tie. Okay, so this guy will win the election if no one is removed. So for the first index, we have the answer 0. That's the minimum number of candidates we need to remove so that this one wins the election, right? Now let's look at it for the second candidate. It's 203. Uh, let's make it 2 plus 1, because for the moment this guy is receiving 3 votes. So suppose this guy wants to win the elections. Okay, so we can see that it will not win the elections because there are two numbers that are greater than him currently. They are 3 and 3. So obviously we'll have to remove both of these candidates so that this wins the election. But there's another thing you need to notice that I guess I missed from the problem statement, is that if we do not allow candidate number I to participate in the elections, all AI of his fans will become undecided and will vote for the candidate with the lowest number. Okay, so let us see how this goes. Suppose if I delete candidate 3, okay, we have 203. Okay, we delete candidate 3, then these 3 guys who are voting for him, they will vote for the first candidate, the guy with the lowest number. See, all of them will vote for the candidate with the lowest number, as they will become undecided. Okay, so this guy will gain the votes of this guy. Okay, so this will now become 5 and this will become 0, and eventually we'll have to delete 5. Then all of these guys, this is 2 plus 1 by the way, so this will become 6 in fact. Okay, and all of these guys will now vote for this, as only this is left, so the answer will be 0 plus 6. It will be 6 candidates will be voting for him if both of these are deleted. So anyhow we'll have to delete both these elements, so answer to the middle element will be 2. Okay, and for the last case we'll see we have 2 plus 1, 0 and 3. Okay. So initially this guy is winning the elections, and this guy now wants to win the elections, right? So how many numbers in here are greater than this number, right? So this is a competitor, we need to remove this competitor. But think, what will happen if we remove this competitor? If we remove this competitor, then all of these 3 guys who are voting for him will now for the guy with the latest number, right? They will vote for him anyways. So this guy will now have 3, and this guy still has 3. So again, this will win the elections, because in case of a tie, the earlier guy is only winning the elections. So one observation you can make is that suppose some guy that's not the maximum. Let's consider we have 1, 2, 3, 4, 5 for the moment. This is the given array, and suppose we are looking out for 3. Okay, so what are the competitors of 3? We have 4 and 5. Okay, let's disregard C. Consider that C has already been added to this element. So these are the two competitors of this number. Okay, we have to delete these elements. Okay, but if we delete these elements, then the number of voters will come to 2. So anyways, all these voters are still retained. These voters don't go anywhere. These elements disappear. So the new element will again become 2 plus 4 plus 5, 5 and 3. So this guy is still losing. So anyways, we'll have to delete the last element. Okay, so the main observation we could make, okay, this was, I forgot 1 year, let's consider one was not there. Okay. Yeah. So what observation we can make is that if there is any number that's let's consider it an ambiguous number k for the moment. We have any number k, and we have number a1, A2, and similarly B1, B2. All these elements, these are elements before k and these are elements after k. And we have any elements that is greater than k. So if we delete that element, then all these numbers will go to the first element. If k is not the first element already, okay. So they will go to the first element and these number of voters will be retained. So first of all, what we will have to do, we will have to delete all the numbers occurring before k. If at all this number has a competitor, then we'll have to uh, first remove all the candidates that are coming before k, because if we remove any element again, uh, the number of voters will again go back to the first element. So the number of voters will be retained. They won't go anywhere. So we'll have to delete all the elements that come before k. You get this much, right? So k will be the first element, and all these elements, they are that are the competitors. If we delete any of these elements, then its votes will be directly coming to k, right? Okay, so this much we got. This conclusion we made, that we will delete all the elements before the given element if this number has a competitor. Okay. Now the thing that I'm mentioning again and again, if this number has a competitor, it means that let's say we have numbers 2, 3, 2, 4, 5 and 4, 5 and 5. Okay. So 5 is the maximum element here. It has only one competitor. Okay. But this is also not a competitor because this is the very first element, very first maximum element that is occurring. And we learned that in case of a tie, this element will win, the first element, right? So this element will have no competitor. Which element will have no competitor? The first occurrence of max element will have no competitor. Okay, so in this case we can win by deleting zero elements only. Okay, for answer for this will always be zero. Okay, what about the other numbers? Can you think? So well, there's another observation we need to make. uh, Let us continue with this example. It's 3 2 5 4 5. I just switched their orders. It's 3 2 5 4 5, and suppose we want to candidate 2 to win the elections. Let's consider that C has already been added to this element. Okay, it's not a big deal. We'll always be adding C to the first element. We'll do that later. Okay. So first of all, there are three competitors of 4, 2. Okay. So if we want 2 to win, we'll have to delete 3 first. Okay, we deleted 3. So now we only have 3, 5, 4, 5. And to the answer, we'll add 1 for the moment. We have already deleted one element. Now, if we delete this element, the maximum currently occurring element, okay, then this number will get added to 2 because this is the first element. Now this will become 7, 4, and 5. And since this is a non-zero positive number, so if we add the maximum element to the positive number, obviously this number will be the greatest number of all, because we just added the maximum element to this number. So this number now becomes the greatest and he wins the election. Okay, so now we do not need to delete any more numbers. We just need to delete the maximum number and add it to the current number. We just need to delete the candidate with the maximum number, right? Okay. So yeah, we just need to delete the candidate with the current with the maximum number and add it to the current, and that will be our answer. So in this case, answers will be 1 plus 1. That will be 2. We deleted 2 elements, one before 2, another 5, and this candidate won the election. So what does our net approach become? Okay, what does our net approach become? So we'll first calculate the prefix sum. Let's take some test case. For example, let's take this test case 5 3 5 4 3 2 1. 5 3 5 4 3 2. Right. Okay. So in the regular case, this candidate will have 8 votes, the next candidate will have 4 votes, the next candidate will have 3 votes, then 2, then right. Okay. So for any element, we'll need to delete all elements that are before it. And once we delete all the elements that are before it, all these votes will come to this element only, the first element, right? Because these numbers have been deleted, then the votes will be coming to the first element. So we'll maintain a prefix sum of all the numbers that can be added. So the prefix sum will be 5. In this case, the first element of prefix sum will be 5. The second element, in fact, it will be 5 plus 3, because you do not have to forget about this c. Okay, the c will be added only to the last element. Okay, so in this case it will be 8, and then it will be 7, and then it will be 6, and then it will be okay, sorry, I'll just take the prefix sum, right? So just a second. Okay, so now first element will have 8, then we have 12, right? Then we have 15, then we have 17, and then we have 18. Okay, this is the number of points that the current element, the first element, gets when all the elements before it get deleted. This is the number of points when the second element gets when when all numbers before it get deleted. Okay, and so on. So this is the prefix sum. Okay, and this prefix sum, this is the current sum that we have. Okay, and the next will be all the numbers here, right? Suppose we have the second element, the current sum is 12, and all the numbers that are after it are as they were before. None of them has been deleted. Okay, so we will compare this number, that the current number is, okay, with all these numbers. Okay, so if this number is greater than all these numbers, then already this guy has won the election. Okay, and by the way, we are considering the guy with no competitors, with a competitor, with one competitor at least, because if it has no competitors, then answer will be 0, as we discussed earlier. So these guys have at least one competitor, and we have deleted all the elements that are before it. Okay, so suppose this number is 12, then we'll have to check among this array that is there any element that is greater than this element. If there's any element that is greater than this element, then we simply cut that element and add it to this element, and then this element will be the greatest, right? We all agree to this. So the answer will be number of deleted elements, sorry for the bad handwriting again, number of deleted elements plus 1 in this case, because this has been added to this, there's one extra element that has been removed. And suppose this number is the greatest and it has no other competitors. Okay, this number is the greatest and no element in this range is greater than this number, then the answer will be simply number of deleted elements. Deleted elements, right? Okay, so this is the simple answer we can get to this. We will take the prefix sum. Okay, we will iterate through the array and create a prefix sum array. We will iterate through the prefix sum, and we'll just check whether there is a number that is greater than the current prefix sum here. In this whole array, is there a number greater than prefix sum here? You can also do this by set. You can just keep deleting elements and then check the maximum element. But we do not even need the max. We do not even need a set to check this. I'll show you how I've implemented this. So we can either maintain a set of elements currently deleted, not deleted, and then we can take the maximum to check whether whether element greater than this exists or not, or we can use some method that I have done. So let's check it out. Uh, let's check out the summation here. Okay, so first we have taken the input n and c, and then there's a vector a. Okay, that's the array. So we have created a prefix sum vector. Okay, in this sum and max. So I've used max to keep track of the maximum possible element in the whole array. Okay, and sum to keep track of the prefix sum. So we have just iterated through a loop and made a prefix sum array. Prefix I equals to sum plus c. You can see that, and yes, maximum will be the maximum possible element. But in this case, if it is the very first element, we'll also be adding c to it. If it's not the first element, we'll not be adding c to it, because the first element by default gets the vote of all the c undecided voters also. That's why we have implemented this condition. We have taken a number ai, and if that I is 0, then to the number we'll add c, and then we take the maximum of maximum. That will be the maximum number among all these. Okay, And there is also maximum index. We have created a maximum index array and a flag. So this maximum index array will be able to track the very first occurrence of maximum element. We're talking about the guy with no competitors, right? We have 1, 2, 5, 5. Then this 5 will have 0 competitors because this has the maximum number of elements that occur for the very first time. Okay, this guy will have a competitor. This guy's competitor is this, but this guy will have no competitor. So for that purpose, we have created a maximum index array, and we have kept track if that number is equals to max. The same condition we have implemented here. If that number is equals to max and flag is 0, then maximum index is 1 and flag equals to 1. Okay, or we could just have broke through the loop when we found the maximum index. It's the same thing. So we have found the index first occurrence of the maximum element in the max index. Okay, and now for the answer, we'll just start it to the prefix sum like I said, with one exceptional case. If it has 0 competitors, if I equals to maximum index, that is the first occurrence of maximum element, then the answer will be 0. Else, p will be equals to the prefix of I if p is greater than equals to maximum element. Okay, so like I told you, we were keeping track of the current numbers that are in the array. Okay, so if p is greater than equals to maximum element, okay, then clearly no other number. If p is greater than equals to the maximum element, then doesn't matter if any number is here. Its p is already greater than the maximum possible element. Then the answer will be simply I. Okay, number of deleted elements. Sorry, not this one. This one. The number of deleted elements. Okay. And in the second case, if p is not greater than max, okay, then we will print I plus 1, because because if p is less than max, okay, then what is the guarantee that p that max is only occurring after p? Okay, let me just clear this clutter. How did I reach this conclusion that p is greater than equals to max? We'll just printed number of deleted elements, and if p is less than max, then we'll number of deleted plus 1. Well, it's a very simple conclusion. Think like this, that we have p is greater than equals to max, like I explained. Then there can be no number that is greater than p. So already we have the first case. You understand that? But if p is less than max, then obviously max cannot be included in p. You see what I'm saying? Max cannot be included in p because p is less than max and all the integers are positive. So max must be ahead of p. This is what I concluded. If p is less than max, then max number must be ahead of p, because if it would have been behind p, the number would have been greater than max. So since it's less than max, max will be ahead of p, and we will delete this max element and add it to p, and answer will be number of deleted plus 1. So you just think about it, you'll get to the conclusion. So this was the answer to D. It was pretty much simple, I think. I could solve it in around like 20 minutes. So the logic is pretty simple, and we can solve it this way. So guys, we have this problem E. After that, we'll also solve C. So they have we have given two binary strings S and T of the same length, okay, and consisting of characters 0 and 1. There is also a computing machine that can perform two types of operations on binary string A and B of same length K. Okay, they have to be of same length. Remember that. Okay. So we have ai equals to ai plus 2 equals to 0. Then you can assign bi plus 1 equals to 1. So if okay, I'll explain what this means later. It's pretty trivial. Again, we have if we have bi equals to bi plus 2 equals to 1, then you can assign ai plus 1 equals to 1, right? Okay. And if you consider the string a equals to sl to sr and b equals to tl to tr, then what is the maximum number of 1 characters in the string a that can be obtained using the computing machine? This is what we want to know, and we have to answer such queries, q queries, from L to R. Okay, and n belongs to 1 to 2e5, and q belongs to again 1 to 2e5. So we have 2e5 queries, 2e5 numbers, and we have to answer from each L to R. Okay. Okay. So here we have, okay, let me explain this. Uh, Consider these two examples S and T. Okay, I'm taking these two examples, and let me just clear the clutter here. Okay, so forget about L and R first, and think about what you can do to solve for the whole string. Obviously, the simple brute force way is to iterate from L to R and see which ones you can convert, and then again we'll convert them, and then you will count them and you will print the answer. That will work in O of n square, or we can say that O of n into q. Obviously, this will not pass under the given time constraints. We cannot iterate all the time from L to R, right? It's not possible. So, what other solution occurs to you? Okay, let's first consider what is the meaning of the problem statement. What operations we can do. So, if we have, let's say we have 2 zeros somewhere in between of string L, string S, and we have 1 and these letters does not matter where I'm dashing these, they do not matter. So this is string T, and there's a, okay, there's a 0, there's a 0 in between. So if there's a 0 in L and L plus 2 index, obviously they're of same length as they're given in the question. So if n and L plus 2 have the same, that is 0, then this element can be converted to 1, right? And similarly, if S is something like this, okay, and T is something like this, 1 something, then again 1, right? Then this element will be converted to 1, right? We have L plus 2 equals to 1, then L will be equals to also 1, right? And when we have to increase the number of ones in string S, so what is the maximum possible number of ones we can get? Obviously, the number of ones that are already there, they will not change, so they will always be constant. What will vary is the number of ones we can convert, right, from zeros. So what if we do one thing? What if we do one thing? First we convert, since we need maximum possible of ones in string T, since ones do not harm anything, it's best to have maximum possible number of ones in string T that you can have, and then convert the zeros to ones. Understand that? Okay. And so what I mean by this, suppose string, the above example, string S is 0 0 0 1 0 0 1 0 0 0 1 0 1 1. Okay. 0 1 0 0 1. Okay. This is string. So this is the maximum possible numbers once we can have in string T. We can have, okay, so this is 0 and this is 0, so this can be 1, right? Yeah. And similarly this is 0, this is 0, so this can be 1, this is already 1. Can this be converted to 1? So both of these have to be 0, this cannot be converted to 1. Similarly this cannot be converted to 1 since there is no L minus 1 element. Okay, so the best possible string we can get here is 0 1 1 0 1 1. This is the best possible string we can get. And next we have 0 1 0 0 1 0. Now what if we do one thing? We have converted this string. Now if we convert this string also, we create the maximum possible of number of ones in the whole string, and in each L2R, and in each L2R query we just count the maximum possible number of ones. What's the problem in that? Actually we can do this, and we are going to do this with one slight modification. I'll tell you what's the problem here. First we'll convert the string string T, because that's the best possible thing we can do. We'll convert the whole string T in the best possible way. We'll create maximum possible ones, and then we'll try to convert string S also, and from each L to R we'll just print the maximum possible number of ones using prefix sums. Okay, now there's just one problem here. Okay, suppose I have taken string L to R, right? Okay, suppose this example only, we have 0 1 0 0 1 0. Okay, I have taken strings from 2 to 1 2 3 4 5 6 7 8. 2 to 7. Okay, and so only we have 0 uh, Okay, what was this? Okay, let's just take another example. So we have a string. Let's say we have 0, 0, 0, 1, 0, 0. Okay, and we have another string 0, 0, 1, 1, 0, 0. Okay, so it can be converted to, since these two are 0, this can be converted to 1. Okay, since these two are 0, this is already 1, and I guess no other matches can be made. So the best possible scenario for this string is 0, 1, 1, 1, 0, 0. Okay, this is the best possible string, and this string will remain the same for the time being. Okay, using these we can also transform this element. Okay, so that we'll do later. So suppose we have taken range from 2 to 2, 3, 4, 5, 6. Okay, let's take to the last element. We have taken indices from 2 to 6, right? So the new substring will be 0, 0, 1, 0, 0, right? And we'll take the old substring only, not the new one, because I'll tell you why. 0, 1, 1, 0, 0, right? Now tell me, here if I include all the indices from 2 to 6, what is the maximum possible number of ones I can get? So since these two are 0, this can be converted to 1, but this is already 1, and there are no other matches from L and L plus 2. So this is the best possible string we can achieve, and there is only one that we can achieve in here, right? We can not increase the number of ones here. But if we took the whole string, you see, this is the modified string, and we'll create we could create one more one, 0, 0, 1, 1, 0, 0. Okay, so this was possible when we included the whole string, but this was not possible when we included a substring. Why did this happen? It happened because this one that I have converted, right? 0, 0, 1, 1, 0, 0. This 0 that I have converted to 1, that happened because this 0 and this 0 contributed, right? These two zeros contributed to the making of this one. But if I include strings from here to here, I am excluding this 0, right? So this one will also be excluded. You understand what I'm saying? Okay. So what conclusion we can reach? And what about the ones that are inside? For example, we have 0, 1, 0 and 0, 1. And what if this is 0? Okay. And this is also 0, 0, 1, 1. Yeah. Okay. So what can be the best possible string for this? We can have this is 0, this is 0, so this will be 0, this is 0, this is 0, so this will also be 0, so these two will be 1, and then this will be 1, this also be 1, so 0, 1, 1, 1, 1, 0, 0. Okay, yeah, so we converted these two zeros to ones also. Okay, so if I take substring from here to here, okay, this 0 will be excluded, so this 1 cannot be included. Okay, okay, but this 0 was included, so this one will be included. This is nice. But if we take some string from here to here, then this one cannot be taken. This one cannot be taken because there was a 0, it was borrowed from outside this segment. So a 0 will be borrowed from outside this segment. If a 0 will be borrowed from outside the segment, then we'll have to delete the last one. Right? This will not be possible. And similarly for the end segment, like the starting segment, if a 0 is borrowed from here, okay, and a 1 is made here, then we have to exclude this one. Okay, and all the other zeros are inside the segment. So if there was any conversion from 0 to 1 between these inside this segment, then it's okay. Then we do not need to change this. Like this will be included because these two zeros were also included in the segment. So the edge case here was that if a 0 is included from outside the segment, from outside, then exclude it. Otherwise, we can just take the prefix sum. there's no problem. Okay. Okay. So how do we check if a zero is excluded? Like, how do we check if the number at the edge is proper or not? Okay. So each time we take an L to our query, right? Each time we take an L to our query, what if we just check the extremes? That if there is a one here and if there is a one here, okay, then clearly it is not possible because this one would have been borrowed from this zero, right? This one would have been borrowed from this zero, so this would not have been possible. Okay. Suppose there is a one here, then it would be possible because it would obviously be borrowed from inside. Okay. This is included. So all the ones inside are included and ones on the edge are excluded. You get that? Otherwise, it's just a prefix. So in each query from L to R, we'll just check if there is an included one. Included means converted ones, right? Because if there's a one from one, there was always a one, like it was not converted. Then why do we exclude it? So it's fine, right? So if there was included ones or converted one in L or R, then we will delete. That's all we have to do. We have prefix of L, R, R. Okay, just clear it and write it down. We have prefix of R minus prefix of L, actually L minus 1. Okay, prefix of R minus prefix of L minus 1 minus excluded. These excluded ones are from the edges from L to R, right? Let's see how I implemented this. It will make the things more clearer. So here's my solution here. Just open it up. So, okay, here we have string SNT, we have taken the input, and there is a prefix and prefix Z. I will tell you what prefix Z is for the moment. And there are two vectors marked 1 and marked 2, right? Marked and marked 2, right? So what have I done? I've iterated from 0 to n, okay, and I've created a prefix sum, prefix I plus 1 equals to prefix I. This prefix sum is for the number of ones, okay, number of ones that are already there, okay, the numbers of ones that are already there in the string. This is what this prefix will include, okay, and prefix Z will include the number of converted ones, right? So prefix Z will include the number of converted ones up to index I. You get that? Okay. So this is just the prefix sum summation, and if this condition satisfies, if ti equals to 0 and I greater than 0 and I less than n minus 1, and if si minus 1 equals to 0 and si plus 1 is also equal to 0, then we'll just convert ti to 1 and we'll set marked of I to 1. Now why am I marking this I? I want to track that this particular 0 was converted. Okay, so this mark will keep track of the indices of zeros that were converted in string t. Okay, this is for string t. Make it very clear. This mark is for string t. Okay. So now we'll iterate from 0 to n. Prefix Z of I plus 1 equals to prefix Z. This is how you initialize prefix into the previous one. And again, if this condition is satisfied, now this new modified string t has been made. Okay, so now we'll iterate again, and if again ti minus 1 equals to 1 and ti plus 1 equals to 1, then prefix Z I plus 1 plus plus. Okay, so this will keep track of the number of zeros that are converted. This was keeping track of the number of ones that are converted. Okay, and this will keep track of the number of zeros that are converted. Okay, so now mark 2 is equals to 1. Now this will keep track of the number of zeros. Yes, this will keep track of the indices of zeros that are converted. So if I convert a 0, I mark it. You get it? Okay. So now I will take in the number of queries and iterate. We have entry L and R. Okay. We have the first sum, that is prefix R plus 1 minus prefix L. That is the number of ones that were already there between L and R. They are always included. Now the second thing we will add is prefix Z of number of zeros that were converted to 1 between R and L. We'll just add them. Okay. Yeah, we'll just taking maximum with 0 in case it is negative. Although it shouldn't be negative, I just take it for the cases in case of safety. Okay, and then we create a flag. Okay, if L plus 1 is less than R, Obviously we do not want to exceed the range. Okay, so if L plus 1 is less than R and Mark 2 is L plus 1, so why are we using Mark 2? For Mark 2 we are keeping track of the number of converted zeros. Okay, so if L plus 1 is a converted zero, okay, and marked L is 1, what I mean by this is, I'll explain to you. This is an L to R, right? L plus 1 is a converted zero. This one is a converted zero, right? And yeah, this one is a converted zero, okay? And this one is also a converted one. It was not there from before, okay? This was a converted one. Then this means that this cannot be converted. Why by this cannot be converted? Because this is a converted one. This was zero. This was zero and this was zero. That's why this is a converted one. And this is one. This is one. That's why this is a converted zero. So this cannot be converted. This will be excluded from the discussion. Similarly, if we take from behind, okay, if this is, to make it more clearer, this is an element, this is a zero, this was converted, okay, and this was also converted, which means here was a zero. Then this will definitely be excluded from our argument, right? This will be excluded. So yeah, this will be excluded. So again, uh, we will exclude both these numbers. If this was converted and this was converted, then not possible, okay? And if this 0 was converted as well as this 1 was converted, then also not possible, okay? But there is one case where we have L plus 1 and R equals to L plus 2, right? Here we will delete, if we delete this element, we do not again delete this element, right? We cannot delete elements both from the first and last because there is only one element, right? Even if we satisfied both the conditions, we delete only 1 0 or 1 1. So we'll keep track of that here. So if mark 2 of L plus 1 is 1 and marked of L is 1, which means the 0 of L plus 1 is converted and 1 of L is converted, then we'll decrease sum by minus 1. Right. Yeah. And we'll create flag equals to 1. It means this condition has been satisfied. Okay. And similarly, we'll check for R if mark 2 of R minus 1 is 1 and marked of R is 1. Right. Like I said, mark 2 of R minus 1 is 1 and marked of R is 1. Right. And this condition I've just taken for the case of R minus n equals to L minus 1, that is R equals to L plus 2. And if this has already been satisfied and R equals to 1 and L plus 2, then we don't do it. If it's not the case, then we'll decrease sum by 1 more. If you think about it a little bit yourself, you will understand yourself. So we'll just print the sum. So this is my logic. Thank you.
This is problem C from Codeforces round 953. You can pause the video and read the problem. The problem states that we have to find a permutation P such that the value of the expression P1 minus 1 mod plus P2 minus 2 mod up to Pn minus n mod is equal to K. Suppose that we have n as 8 and K as 20. Suppose our permutation is so we will try to swap some numbers. Suppose we swap 1 with 8. So you can observe that if we consider this permutation, its Manhattan value will be equal to 0. Now let's suppose that we swap 1 with 8, its Manhattan value will change by 8 1 in 2, which is equal to 12. So in this problem, we will be using greedy method to solve it. What we'll do is that in our in the permutation that we take, we will keep on subtracting the maximum value that we can obtain after swapping any two numbers. What I mean to say is that suppose we first swapped 8 with 1, and we can observe that this is the maximum, this is the first maximum that we can obtain after swapping any two numbers, and its value is equal to 12. Now the value of k will update 20 minus 12, which is equal to 8. Now we have swapped 8 with 1. Now we will find the next maximum that we can subtract from k. So the next maximum will be obtained when we swap 7 with 2, and its value will be. So we observe that if we swap 7 with 2, the value that we will get is 10. But the value of k was 8. So we won't swap 2 with 7. Instead, what we will do is that we will next try to swap it with 6 and 2. So in this case, its value will be. So we found that after swapping with 6 and 2, the value we get is 8. So the k will be updated with minus 8, so 6. So what I will do is that I will be using two pointers method to solve this problem. So I will maintain point two pointers at the start and end. First here and second here. And so in this case, when we will swap these numbers, the value we will update k accordingly. And suppose that after swapping the numbers, the value we got was greater than k. So what we will do is that instead of swapping with that number, suppose that after swapping with 8 and 1, the value we got was greater than k. So what we will do is that we will swap with 7 and 1, and we will keep on repeating this process until the pointers don't cross each other. That is, this pointer and this pointers, they don't cross each other. So here is the code that I found. So first what I have done is that I have created a vector arr, and I am using one based indexing. So I have initialized my vector with values arr I equals to I, and I have maintained two pointers, one at the end and another at the start. And I have done a for while loop while a is less than b and the value of k is greater than 0. So I will swap a and b, and I will check if after swapping the value is less than k. I will update k, and then what I will do is that in the question we have to give the permutation. So we will store what the numbers that we have swapped. In this case, originally the at place of a the value b will come, and at the place of b the value a will come, and we will move to the next index. And suppose that this condition becomes false, so what we will do is that we will decrease the pointer which was pointing to the maximum, and we will keep repeating this process until the two pointers don't cross each other or the value of k don't become 0. So if the value of k is greater than 0, so in this case the output will be no, or else the output will be yes, and we will print the error.